We go to question number 778, swim in rising water. This is hard question. Let's get into it. This question has a lot of sum up. On an n by n grid, each square grid I and j represent the elevation at that point I, j. Now rain starts to fall at time t. The depth of the water everywhere is t. You can swim from a square to another for directional adjacent square if and only if the elevation of both squares individually are at most t. You can swim infinity distance in zero time. Of course, you must stay within the boundary of the grid during your swim. You start at top left square 0,0. What is the least time until you can reach the bottom right square n minus 1, n-1? Okay, let's check with example 2. In this time we start from here, so elevation is 0. So if we're going to here, we need to waiting 1 second. Because after 1 second, this water is the fill only 1, so this level is same as this one. Does this make sense? So now we are here, and then to go to here, we needed to waiting 1 second, because it also take time 1 second to fill water, same as this one. And 1 second, 1 second, 1 second, and then we need to waiting 11 seconds to going up to this is 11, right? 11. So after 11 seconds, this 5 and then fill water is the 11. So now we are able to go to here. And then next is smaller, so take no time, 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 no time. Finally, it take 16 seconds. Does this make sense? Okay, cool. Today, actually there are maybe several approaches using heap. Heap also we can use heap, and there also we are also able to use union find. But today I'm gonna use BFS with hash map because that is optimal solution. Other solution using heap and because other solution using heap and union find, it take n over m time complexity. Okay, let's implement the code. So this is test data, and then okay, my solution is using BFS plus hash table. First I'm gonna make hash table levels, and then use collection default fix and then list. The reason is, okay, let me simulate it. First levels, and then this is start point, right? So start point level is 0, and then I put 0, 0. Next, I will try to move next, and then 1 and 24. If this one is bigger than 0, at this time we cannot go because we needed 2 waiting time. So after 1 second passed, we are able to go to here, right? So in this time, I will go put the 1 is 0,1, and then 25 is 1,0. So first is only run here, but next time t is 1, we can use all of this one. Does this make sense? So I will use this one. So first select dictionary, and then second Also, I need to VGT check. So VGT set. So do not go back. And then next, I do animator loop, and then if t in levels, and then I will make Q DQ using I'm gonna use DQ, and then for row and column in level T, I get all of data from level T. This case, if this is 1, I will go in all of this one to the put and then to BFS. And then next time I will get the times to point, and then I will do BFS. Does this make sense? To do that, maybe I can reach that within this time. Okay, let's implement the code. Okay, then this time the time complexity is big OT, and then T time T is permutation to n-1, so we can say this is the n, and then n square, right? The n square is the linear time, because this is the represent the row and column. So let's say the scanned grid is linear time, this one is linear time, and then space complexity also n square, and then we can say linear time with linear space. Okay, let's implement the code. First, let's calculate n is length grid, and then make the VGT levels. Collection, default big, then list. Next one, VGT set. Then okay, this is okay, and then levels grid 0, 0 start point, append 0, 0, and then also VGT add 0, 0. Do not move again, and then also we need to neighbor. Neighbor is top, bottom, left, right. Okay, and then we need to calculate T is grid 0, 0. That is start point. So okay, let's iteration while I will do infinity loop, and then if T in levels, and then first I would like to make Q to DFS. Q is I will use collections DQ, and then I will full all level this one to the Q. So for row and column in levels T, then put into the Q. Q append row and column. After that, let's do BFS. First, let's get pop row and column in this Q pop left, and then if row is n-1, this is the goal, when we reach the goal, return T. Otherwise, we need to go to neighbor. For labor row and labor column, we will get one by one from neighbor, and then change relative location to absolute location, row into row, and then column, and then let's boundary check. And BGT to check. That time. There are two choices. First, grid and allow. Next, neighbor column is small equal to T, then is to be able to BFS at this time. So at this time, I put in the Q append and row and column, and then I will T add and row and column. Otherwise, I will put into the label for next BFS. So label, grid, row and column, append and row and column. Then to finish it, I will increase T plus 1. Okay, let me final check. Neighbor is 101 correct, and then max is grid correct, label is collection default list correct, and then BGT set correct, and the label put the start point. This is the elevation of start point, and then this is location of start point. And after that, I will do BGT add. So next is T. T is start with the same as start point. And then T is label. At the time has to be 0,0 is pop up 00, and then YQ 00. This one is not final, so I column neighbor. Now column and now column is not BGT'd. Grid and now in the column smaller T, Q append, BGT and now column as label, grid and now column. Okay, it looks good. Okay, cool. Okay, time complexity is it take big O T, but T is same as N because there is permutation M0 to N minus 1. So we can say time complexity is N square linear time, and then space complexity also N square linear space, because we use not only default dig and then BGT and then Q. Thank you.